Alright, today we're going to solve systems of equations graphically now. There are three possible scenarios here. You can have two solutions, which means the quadratic and the linear cross twice and have two intersection points. You can have one solution where the quadratic and the linear only touch once, and you can have no solutions where the quadratic and linear will never cross one another. And that was just like the last example from yesterday's video where we had imaginary solutions. So that just means it will not intersect. So an example would be y equals x squared minus 6x minus 1 and y equals negative 2x plus 4. So now in order to solve systems of equations graphically, you have to be familiar with how to graph both a quadratic and a linear. And if you're solving a circle and linear, you're going to have to be familiar with how to solve a circle and how to graph a circle and how to graph a linear. So to graph a quadratic, let me just first set up a set of axes here. And to solve a quadratic, what I'm going to do, I'm going to find a turning point which will help me find the middle of my tables. I'm simply just going to put a table of values for my quadratic there. And to find the axis of symmetry, I'm going to say x equals negative b over 2a, which in this case is negative 6, so 6 over 2, so 3, which means my middle value in my table will be 3. So now all I'm going to do, I'm going to go to my calculator and copy a table of values. Let's see. So I have in my y equals, wow, a lot of different equations in there. Let me clear all them out. I am putting in x squared minus 6x minus 1. Y equals x squared minus 6x minus 1. And then I'm just going to my table of values. And, well, my table set is all messed up. Table start at 1. So, here's my table of values. And I'm just going to copy this table of values here. Now, my calculator is all messed up because this is from when I was in high school. So, you just got to learn how to kind of deal with this kind of stuff. So, here are my table of values that I'm just going to copy. The middle value will be 3. And I'm just going to copy all of my corresponding y values. So I'm going to have from 0, 1, 2, 3, 4, 5, and 6. There's 7 ordered pairs in which 3 will be the middle. I determine that with the equation of the axis of symmetry. So now when x is 0, y is negative 1. When x is 1, y is negative 6. When x is 2, y is negative 9. And when x is 3, y is negative 10, and then we're going to have repeating values from there. So here are my table of values for the quadratic. Let's plot those. 0, negative 1, 1, negative 6, 1, 2, 3, 4, 5, 6. And I'll need to get rid of this. Fit my graph on there. Let's see, 1, negative 6 I got, 2, negative 9, 2, negative 6, negative 7, negative 8, negative 9, and 3, negative 10. So here are all of my ordered pairs for y equals x squared minus 6x minus 1. So let's plot these. Make it look like a parabola. Finally, I need to graph my linear. So I have a y-intercept of positive 4, 1, 2, 3, 4, and a slope of negative 2. So down to right 1, down to right 1, down to right 1, down to right 1, down to, well, there's a solution. And let's plot that. So now what I like to do is exactly as I showed. I like to plot every single ordered pair to find a solution. So now it looks as if we have one solution here, but that's because we need another x value here. If we plug in x equals negative 1, we're going to get an ordered pair up there. There are two solutions. That arrow means this graph continues in that direction. This arrow means this graph continues. So if I connect both of these, it's going to cross. Let's figure out where. When x is -1, let's go back to our table of values from the calculator, then y is 6. So -1, 1, 2, 3, 4, 5, 6. So that's an ordered pair from the quadratic. And it's also an ordered pair for the linear, which means it is a common ordered pair. So the solution of this system of equations, it crosses twice, and those values are at -1, 6, and at, which ordered pair was this? 1, 2, 3, 4, 5, -6. One more example. Let's say we have y equals 2x squared minus 7x plus 4, and y equals x minus 4. So now if I found the equation of the axis symmetry here to find the middle of my table, x equals -b over 2a. I have an odd value of b. So x equals 7 over 2, which is 3.5. So 3.5 is going to be the middle of my table. So I'm going to have x values, I'm going to have y values, in which my middle value will be 3.5, but I'm not going to plot that. Now I'm just going to have 6 ordered pairs. I'm going to approximate this. So now my middle value will be 3.5, but again, I'm not really going to use that ordered pair. I'm just going to say 3 and 4 will be the middle of my value. So I'm going to go 3 ordered pairs above and 3 ordered pairs below. So 2, 1, 5, 6. Now I'm going to plug that into my y equals. I have 2x squared minus 7x, and you can plug this into your calculator while I'm doing it, and second table, and you'll see that when x is 1 and y is -1, when x is 2, -2, when x is 3, we have 1, when x is 4, we have 8. Did I put this in correctly? 2x squared minus 7x plus 4. Yeah. So our table of values, 8, 19, and when x is 6, y is 34. So we're not going to be able to plot a lot of these ordered pairs. But this is enough. So let's plot this, and let's plot the linear. So let's set up a set of axes here. My phone is ringing, that's why I didn't use my phone as a straight edge this time. So let's first plot the linear. We have a y-intercept of -4, 1, 2, 3, 4, and a slope of 1. So let's just plot every single ordered pair we can possibly fit. Slope of 1, so rise 1, run 1, rise 1, run 1, all that nonsense. So let's connect it with a straight edge now that my phone's not ringing anymore. There's our linear. Let's plot our quadratic now. 1, -1, 2, -2, common solution. 3, 1, 3, 1, 4, 8, 4, 1, 2, 3, 4, 5, 6, 7, 8. Oh, this was 7 over 4. That's why we messed up there. The axis symmetry is wrong, so we should have went the other way. When x is 0, y is 4. So 0, 1, 2, 3, 4. So that's enough. Here's our quadratic, which only touches the linear once. One solution. The linear equation is tangent to the quadratic equation. And just to show you why our table looks a little messed up, I messed up with the axis symmetry here. I forgot to multiply by 2a. A was 2. Therefore, our center is 7 over 4. So I should have just went up a couple more ordered pairs. Although I got the idea of how the quadratic looks, my table was a little far down. I should have went up a little more on my table. But we got the common solution of x equals 2 and y equals -2. Only one solution here.